Welcome you again. Today we'll be discussing a few questions from the current electricity. One of the questions that is most important, that is the relationship between, derive the relation between current and drift velocity. There is also another question, what is current density? There is also another question, how to derive Ohm's law using drift velocity concept. These are 2-3 questions we will be deriving one by one. आप सिर्फ कुछ फॉर्मूलाज याद रखें कि हमने कैसे लीनियरली सॉल्व कर सकते हैं. पहला क्वेश्चन करेंगे सॉल्व. शो दैट I is equal to MEAVD or derive the relationship between drift velocity and electric current. ये हमारा पहला होगा. हम सिंपली यहाँ याद रखेंगे कि हमें जिस हिसाब से क्वेश्चन पूछा जाएगा उसका आंसर हमें सिंपली उसी वर्ड में लिखना है. यहाँ ज़्यादा इंटरप्रेट या ज़्यादा डिटेल करने की ज़रूरत नहीं है. जिस हिसाब से क्वेश्चन आ रहा है तो हम देखते हैं कि एक कंडक्टर है. आप सिर्फ पॉइंट्स याद रखें. से the length of conductor is L. Let's consider conductor of length L and area of cross section A. आप कैपिटल A भी लिख सकते हैं, स्मॉल A भी लिख सकते हैं. And area of cross section A, uniform area of cross section across the conductor. It's of uniform area of cross section. So we have area A. Let us apply a potential difference V across the ends of the conductor. So here will be positive charges on this surface, and on this surface there will be negative charges. Before this, applying this potential difference, कंडक्टर में जो चार्जेस थे, इलेक्ट्रॉन्स थे, वो रैंडमली थे. They are moving randomly. लेकिन और इनका नेट इफेक्ट 0 होता है. लेकिन जब हम पोटेंशियल डिफरेंस अप्लाई करते हैं, पोटेंशियल डिफरेंस की वजह से यहाँ से पॉजिटिव चार्ज डेवलप हो जाते हैं और यहाँ पे नेगेटिव चार्ज डेवलप हो जाते हैं. यानी कि ये साइड पॉजिटिव बन जाता है, ये साइड नेगेटिव बन जाता है और यहाँ पे इलेक्ट्रिक फील्ड डेवलप हो जाता है. ये this without applying or before, when there is no potential difference, these particles or electrons are randomly moving and the net effect is 0. There is no current at all. Simply. जब आप potential difference apply करते हैं, then what happens? जब हम potential difference apply करते हैं, when we apply the potential difference V, this V will create an electric field E, and that is given by V by L. This is one of the form of the potential difference across these two ends creates an electric field E, and you know the potential per unit length or with respect to length is a potential gradient. So this is the one of the formula that you have to remember, that E into L is equal to V. Now, when electric field is created, the electric field creates a force, and you know the electrostatic force creates a force per unit charge. The electric field creates force on charge. अब यहाँ पे जो इलेक्ट्रिक फील्ड पोटेंशियल डिफरेंस जब हमने दे दिया तो वहाँ पे ये पॉजिटिव साइड बन गया, ये नेगेटिव साइड बन गया. ऑब्वियसली जो पॉजिटिव साइड से इलेक्ट्रिक फील्ड की डायरेक्शन इस साइड होगी, इलेक्ट्रिक फील्ड की डायरेक्शन इस साइड होगी, और जो नेगेटिव चार्जेस हैं यहाँ ऑब्वियसली इलेक्ट्रिक फील्ड उन्हें अपनी तरफ खींचेगा. द मोशन ऑफ इलेक्ट्रॉन इज अपोजिट टू द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. The motion of these negatively charged particles in this conductor is opposite to the electric field, because electric field is from positive to negative, and it will attract all electrons towards itself and will drift them. These all electrons, जितने भी यहाँ पे electrons हैं, they will be drifted with a drift velocity Vd. So there is a term drift velocity. यहाँ पे हम drift velocity simply लिखेंगे क्योंकि drift velocity is the average. Actually, drift velocity is average velocity of each particles. We take them as V1 plus V2. If it is V1, this is a V1 velocity. It's a V2 velocity. It says V3. Then we take V1 plus V2 plus V3 and take an average velocity. Now we consider, for simplicity, because this is a more pattern, we consider that each and every electron is drifted by this electric field created by this positive plate towards itself, and direction of these negative charge particles will be opposite to the direction of the electric field, and this is known as conventional current. The current produced is a conventional current. And conventional current, the direction of motion of electrons is opposite to the direction of current. So current will be moving in this direction and electrons are moving in this direction. So electric field will be opposite to the motion of the direction of electrons, and the current will be in opposite. Current will be moving this end to this end, while electron will be moving this end to this end. While these electrons are moving, they are drifted by this electric field. This electric field drifts them with a velocity Vd. So there is another term, velocity Vd. And this electron from this cross section area will move up to this end, traveling a distance L. So total distance a charged particle travel through a conductor is a L, because length of conductor is L. And the time taken from this to this is a relaxation time. That's also taken as actually an average time. So हम उसको लिखते हैं tau. The time taken from electron from this very point to this very point is, say, suppose tau, called relaxation time. And we have drifting velocity Vd, we have another term tau, relaxation time, also known as time. And we know the relation between velocity, time, and distance. The velocity is distance bata time. So we get drifting velocity is equal to distance bata time, or tau is equal to L by Vd. D is a substitute, means drifting velocity. This is a relation between time and length of conductor, means the distance traveled by the charged particle, and V is the velocity. It's another formula, E is equal to V by L. You have to remember it. And there's another formula that this electron, when you apply the potential difference, there is an electric field E, and electric field E will create a force on each charge, say it is Q. So the electric field will create each force on each electron. So then F can be written as E into E. So the force experienced by all these electrons will be F is equal to E into E. So I can write E into E is equal to F, and this is electrostatic force now. But this electric field creates a force on each charge and drifted them from this end to this end. Well, that means these electrons are being accelerated. They are drifted. They are being accelerated from one end to another end. So that means there's an acceleration of each electron. So we can convert this M into A is equal to E into E using Newton's second law. Electric field creates force on each charge. That force accelerates the electrons, creating the acceleration, and mass is the of each electron. So acceleration is equal to E over M. This is another formula you have to remember or you have to mind. So V is equal to E by L, and acceleration A is equal to E into E divided by M. Another formula. This is the acceleration of the electron, acceleration of the charged particle under the influence of electric field. Under the influence of gravity, there is an acceleration called G, small g, acceleration due to gravity, and that is constant for everything. But in case of electric field, when you insert a charged particle in an electric field, the electric field will accelerate the charged particle with different acceleration. There is no constant acceleration as it is in case of gravity, where G, small g, remains constant. When you drop the object or when you throw the object into the space, the object falls on the surface of Earth under the influence of gravity. At that very moment, small g is constant as 9.8 for every object without a dependency of mass. That's mass independent. But in case of conductors or in case of electric field, when you draw a charged particle in an electric field, the acceleration varies with respect to mass. So you can vary the mass because acceleration inversely proportional to mass of charged particle. So mass of proton is greater than mass of electron. So hence acceleration of electron will be greater than the acceleration of proton in case of electric field. So acceleration of electron will be greater than the acceleration of proton in case of electric field because proton का mass ज़्यादा है और acceleration is inversely proportional to mass. प्रोटॉन का मास ज़्यादा है तो एक्सेलरेशन कम होगी इलेक्ट्रिक फील्ड में. इलेक्ट्रॉन का मास कम है तो एक्सेलरेशन ज़्यादा होगी. अल्फा पार्टिकल का मास ज़्यादा है तो ऑब्वियसली एक्सेलरेशन कम होगा. So this is the formula that you need to remember this. और हम कैसे निकालते हैं स्टेप बाय स्टेप all those very points. Now consider this is in the volume of this conductor is now volume is equal to A into L. And there are n number of charges and each has charge E. The total charge बाकी आप वो स्टेटमेंट लिख सकते हैं स्टार्टिंग में. लेट अस कंसीडर अ कंडक्टर ऑफ लेंथ L, area of cross section A, let n be the number of charged particles and A the cross section L with the L give the volume, the total number of charged particles. As you know that Q net will be equal to n into E, the total number of charges, and that is in volume, that is AL. So n is the number of charged particle, E is the charge of each electron, and AL is the volume containing those very charges. So this is the net charge. Hence, we can write current I is equal to Q net over charge per unit time. Right? That I said you we will take an average time tau. Instead of t, we write a tau. We can write a tau. So I is equal to this Q net is equal to N E A L divided by tau. And you can write, there are two ways to find out the proof. You can say that this charged particle will travel at distance L. Total distance per unit time gives drift velocity. Or you can write I is equal to NEA L. Again is this tau. I can write L by VD. L divided by VD, that is equal to, so I is equal to NEAL divided by L into VD. L and N cancelled. I is equal to NEAVD. This is the one way. Or you can write here simply that we have taken the average charged particle, take the distance from one end to another end. So you can write L by T as VD. So I is equal to NEAVD because L by tau gives VD. So these are the expressions for the I is equal to NEAVD. You have to remember this simply. If you've been asked, derive the expression or derive I is equal to NEAVD or show derive the relation between current and drift velocity, you can simply write this is the conductor of length L, the net of cross section A. The net charge in the conductor is, we know the rate of change of current is Q by net time T. T is the tau actually, the time of each particle that it takes from one end to another end. You can convert that in terms of drift velocity and distance. So you get this very formula I is equal to NEAVD. So after getting I is equal to NEAVD, how we can continue for next question. So now I is equal to NEAVD, we proved it. Now relation between current density. So I is equal to NEAVD. And you know the current density is denoted by J. It's a vector quantity, current density, because all the charged particles are perpendicular to the surface of this cross section. On the cross section, this perpendicular, so there is a particular direction. Current density is the current per unit area. This cross section area falling perpendicular on this area. So I can write this A को यहाँ में ले जाऊँगा. So I over A is equal to NEAVD. NEVD. This is J. So J is equal to NEVD. The relationship between current density and drift velocity. So you can take easily A on this side, it becomes I by A, this is called current density J, and it's a vector quantity. You can write it like this. If you are supposed to write the current density in terms of an expression or in sort of form, you can write let DI be the small current falling on a small area dA, then small current is equal to J is constant into dA, but into is a dot product here. Because I told you the electrons must fall perpendicular on the surface of cross section, so there's a dot product. So you have a J dot dA. So for total current you will get by integrating dI is equal to for whole surface S J dot dA. Then integral is I, so I is equal to S J dot dA. This is another expression. you can have between current and current density relation. The total current density can be derived like this, the total current in the conductor. This is another question you've been asked. Derive this one. Or what is current density J? Current per unit area, surface area is the current density J. We can go for the next question same way. So if we have A is equal to, now deduce Ohm's law from drift velocity, or derive Ohm's law from drift velocity. इससे हमने Ohm's law को derive करना है. आप कैसे करेंगे? आप you know I is equal to NEAVD, and you also know E is equal to V by L. From this very equation you can write, I can write E is equal to, we will substitute here. So I is equal to NEAVD. Here it's acceleration. A is equal to EE over M. This acceleration I can write in terms of drift velocity, that is VD over tau is equal to EE over M. Or I can write drift velocity VD is, this acceleration is velocity per unit time. Instead of time I write tau is equal to tau into M. This is the way. I substitute with VD here. So I get I is equal to NEA into this E over M into tau. So I comes out to be equal to N E square A, N E into E square A tau over M into E. I will put down this equation here. I is equal to N E square A tau over M into E. I will discuss it later, but actually I'll discuss out of that. Here I write I is equal to N E square A divided by M tau. This E can written as V by L. This E can be written as V by L. Right now, I comes out to be N E square A tau, N E square A tau divided by ML into V. इसको मैं यहाँ ले जाऊँगा, इसको यहाँ डिनोमिनेटर में लाऊँगा. So I can write V over I is equal to I को यहाँ पे divided by ML divided by N E square A tau. ML divided by N E square tau into A tau. This term, you have a length of conductor constant, mass of each charged particle constant, n number of constant, E constant, A dot cross section is uniform, tau can be written as constant. So you can have a V by I is equal to R, where R comes out to be equal to ML divided by N E square A tau. So this is V is equal to IR, I write this constant and I write V is equal to I. This is the Ohm's law. This is Ohm's law. The status that under the conditions of physical conditions of temperature and pressure, the potential difference is directly proportional to current I. That I calculate R. This I is equal to IR, where R is constant proportionality, the ML divided by N E square A tau. This is the direction of Ohm's law from the drift velocity. We have a third question. First question was I is equal to NEAVD. Second was current density, and third is how to deduce Ohm's law from the this drift velocity. You can move serially, and you can get the questions what will be asked in the examination, and accordingly you will put down the answer. Now, I hope I put down this. Now I write V is equal to IR, and I got R is equal to M divided by N E square tau divided by ML. Now, there are resistivity. What is resistivity? Can write another question. What is resistivity? So I can write R is equal to M constant, N constant, E constant, tau constant. I will M divided by ML and E squared tau into A. I put these constants. That's rho L by A. Because M is constant, N is constant, E is constant, tau is constant. So R is rho L by A. And I can write R directly proportional to L and R inversely proportional to area of cross section. These are the factors on which resistance depends upon. These are the factors on which the resistance depends upon. The resistance depends upon the length of conductor and resistance depends upon the area of cross section. Now, what to define the resistance is the opposition of current, and this resistance is equal to M N E squared tau L by A, and I have introduced a constant proportional to resistivity rho is equal to M divided by N E squared tau. So the tau is inversely proportional to resistivity, inversely proportional to relaxation time, and tau directly proportional to mass. So these are, you can have many points out of these very equations, but this R is directly inversely proportional to A, R is directly proportional to L, and R is equal to rho L by A. This rho is known as resistivity. Suppose if L is equal to 1 meter and area is equal to 1 square meter, then R is equal to rho. Hence, resistivity is the resistance of a material whose length is 1 meter and area cross section is 1 square meter. It's also known as specific resistance or resistivity. And you can right? Rho is equal to R into A by L. Rho is equal to resistance का जो unit है, that is ohm into meter square divided by meter. Meter cancel. तो resistivity का जो unit आएगा, that is ohm meter. The unit assigned of resistivity is ohm meter, and resistivity is the resistance actually of a conductor whose length is 1 meter and area of cross section is 1 square meter. And resistivity is itself equal to M divided by N E square tau. And it's inversely proportional to tau if I keep all these factors constant. And resistance is itself ML divided by N E square tau into A, area of cross section. This is how you can difference the resistivity and resistance. And the reciprocal of this resistivity, if I take the reciprocal of resistivity, is known as conductivity. इसका उल्टा हो जाएगा उसका unit. तो the reciprocal of resistivity is known as conductivity. Now, this was all about resistance and conductance. Since I wrote here the equation I is equal to N E square A tau E over M. If I take this A here, it's I by A is equal to N E square tau divided by M into E. This is a reciprocal of what we did. Resistivity was M is equal to M divided by N E square tau. And we did a reciprocal 1 by rho is equal to N E square tau divided by M. This is conductivity, as I said, N E square tau over M. Here it is same. So you can write I by A is current density J. J is equal to sigma into E. This is the relationship between current density and electric field. There is a relationship between current density and electric field, but this constant, or you can write J is directly proportional to E. This constant is known as conductivity, that is equal to N E square tau divided by M. As I said, this is a reciprocal to resistivity. So resistivity is inversely proportional to, now I write this is reciprocal of known as conductivity. So resistivity is directly proportional to resistance time, whereas resistivity is inversely proportional to realization time, and conductivity is directly proportional to realization time. So this is the equations you can have. Three or you can be asked any question out of this very portion, and you can, from knowing these formulas, knowing how it can be derived, you can use any way to answer or put down the answer of any question that's asked out of this very portion. So what did we calculate today? First question was I is equal to NAVD. Second was current density and its relation, or current density theorem. And third was that detection of Ohm's law from drift velocity. Fourth was the relationship between current density and electric field, and conductivity and resistivity. This is all about the first part of current electricity. We'll go for the next part soon. Thank you very much.